Welcome everyone. Today I am joined by Professor Rama, who is a professor of practice in AI and machine learning here at MIT Sloan. My name is Michelle Lee. I'm the Director of Business Analytics, and we're really excited to have a conversation with Rama and his journey here at MIT. So to start, Rama, could you please introduce yourself to the audience and tell us about how you arrived here at MIT?
Yeah, sure. First of all, Michelle, thanks for having me here. It's great to be here. So I'm actually an MIT alum myself. I grew up in India, then I came to MIT for graduate school. I got my master's and PhD in operations research here. And then I went on to industry. I spent a number of years at McKinsey, and then I got bitten with the entrepreneurial bug. So I was essentially an analytics entrepreneur for 20 plus years. I was involved in a bunch of startups. All these startups, the common thread was that they would identify an interesting business problem, which seemed amenable to a sort of an analytics data modeling sort of approach. We would build a solution, we would take it to market, and then we would try to convince people to use it and get value from it. After doing it a bunch of times, I had the opportunity to join the faculty here at Sloan as part of the operations research and statistics group. So at Sloan, I'm a professor of the practice, as you mentioned, and I teach courses broadly in the data science, machine learning, deep learning areas. And my research really focuses on how do you take predictive AI and generative AI and make it really useful and practical for business decision makers and technical leaders in businesses. That's really my primary focus. I do advise a number of large companies and a number of startups on how to essentially build intelligent products and services.
Wow. How did you get started with GenAI? Because GenAI hasn't existed for that long.
Right.
What was your path there?
Well, actually, as I mentioned earlier, I teach courses in deep learning and data science, broadly speaking. And one particular course that I've been teaching for about 4 years now is a course called Hands-on Deep Learning. And as folks might know, generative AI is actually built on deep learning. It is, in fact, an application of deep learning. And so since we were teaching deep learning, we got exposed to generative AI very early on. We were sort of teaching about generative modeling and generative AI well before ChatGPT hit the mainstream. Of course, we, like everyone else, were super surprised at the reaction that ChatGPT evoked in the public. And since then, we have just been tracking the research, we have been following the applications, we've been seeing the diffusion of this technology into sort of businesses and so on. And so I have essentially sort of gotten sucked into this rabbit hole in a big way. And so I spend a lot of my time keeping up with the technology and then specifically thinking about, all right, this sounds really cool and exciting. How do we make it practically useful to businesses? Oftentimes executives come to me and say, things are changing so fast. Should we, stand on the sidelines and wait for the dust to settle? Or should we sort of dive in and see what's going on? How do we dive in without taking undue risks? So these are all questions that, to answer properly, you need to be standing at the intersection of the technology and business, and therefore bring a very pragmatic lens to the whole thing. So that's sort of what I do most of the time when I'm not teaching. But I hope that gives you a sense for how I got pulled into GenAI.
Yeah, that's great. And while you are teaching, you're teaching companies, for example.
Indeed.
Could you give us an overview of your course, the hands-on deep learning course, and how it evolves over the semester, and what do students experience in the course?
Oh yeah, absolutely. Hands-on deep learning is a very interesting course because, first of all, it's a course that's situated in the business school, yet it actually is quite programming heavy. So one might think on the surface that, business school students, MBA students, perhaps, are not that interested in programming. But what I saw in the early years when I joined the Sloan faculty is that there's a fair number of people coming to Sloan in the various graduate programs who are sort of not content with just reading about things. They actually want to build things. And so we felt that there was indeed demand and value for having a course which not only teaches you how these things work, but actually shows you how to build things that work. Every lecture ends up being, maybe half of it is sort of a traditional lecture. And then the second half ends up being, we will essentially, fire up a Jupyter notebook or a Colab notebook and then do some live programming in front of everybody. And I think and they can see the model or the system essentially taking shape before their very eyes. And that has a very huge impact on people, particularly those who may not be very used to programming, because they can see that, even people like me who have been programming for a long time, we will make mistakes. We will course correct. We will sort of figure it out as we go. And I think all of it is part of the ethos of the class. So I actually tell students in the very first lecture that my promise to you is that if you have a great idea for a product or service, you don't have to call your techie friend for help. You can roll up your sleeves and build the 0.00 version of the thing yourself, and then you can go from there. So in some sense, the course could literally be called AI for builders, as opposed to just AI for managers. And I think it is for that reason, for instance, like the MBAn students find it super interesting, because MBAn students are builders. They're not content with just reading about things. They actually want to build things. They want to make a difference to the world. So that's really what the course is about. And I guess the final thing I want to add is that the course is extremely action-packed, in the sense that we go from zero to the cutting edge of AI in literally 12 lectures, which means that things happen at a dizzying pace, number one. And number two, very often we have these live demos in the class where, we will build these things in front of everybody else, and then we'll just put it to the test in front of everybody. No canned demos. These are all live demos in the wild. And I think that's all part of the mix that makes the course very exciting to not just the students, but also to the people like me who teach it.
Could you give us an example of a live demo?
Oh yeah, sure. So for instance, when I teach how to do image classification, which is a computer vision problem, what we do is we actually, we web scrape 100 handbag images from the internet, another 100 handbag images of shoes, images of shoes from the internet. And then we say, okay, with these 200 images, can we actually build a shoe handbag classifier? And we build it from scratch in front of everybody. And then once I build it and the model is ready, say 20 minutes in, I invite a shoe or a handbag from the class. So we actually have students come in with their shoes or their handbag, and they literally, put it in front of the camera and see if it works. Fortunately, the last 4 years, it has worked every single time. But I will confess that till it actually works, I am a little nervous. You never know, right?
Yeah. Very cool. And is everything, can you talk about the technology stack? Is everything done in Python?
Yes, the course is 100% Python. We do everything using Google Colab, which gives you access to GPUs. We also actually, allow the students to subscribe to not the free tier, but a paid tier. Sloan will, take care of those costs so that students have access to more powerful GPUs for their work. And so far we have been using Keras, which is a very popular deep learning framework. And I want to say that the final project the students complete in the course, they're very exciting. And I'm always super thrilled to see the way in which students take the things that they've learned in the classroom and then apply it to actually build something which is very significant and often substantial. And in the past, students have talked to me about actually taking what they have done in their final projects and creating a startup out of it.
Well, you would be the perfect person to talk to about startups.
Well, I've done my fair share of startup mistakes, so yes, I have something to offer, certainly on that front.
So what do you see for the future for GenAI and deep learning?
Yeah, that's a very difficult and profound question, Michelle. So first of all, I do think that there is lots of things going on in deep learning that have nothing to do with generative AI. And those applications are, in my opinion, unalloyed good things. Meaning, if you look at things like protein folding, right? We have solved protein folding, AlphaFold. And there are so many incredibly beautiful and successful applications of deep learning. So that is going to continue to accelerate. I have no doubt about it, and I'm all for it. Now, generative AI is different in the sense that incredibly powerful, very versatile, and we are seeing massive impact, positive impact from GenAI in terms of, healthcare and drug discovery and things like that. But I think we should also be fully cognizant of the fact that, given its ability to do various knowledge work tasks, that there might be negative impacts on employment and jobs in the economy. Of course, we have heard about the fact that these are very energy guzzling systems. So there's going to be an impact on carbon and emissions in the environment. So I think with generative AI, I think massive positive impact is certainly possible, but there is some possibility of negative impact as well.
Mm-hmm.
And we as decision makers and builders and modelers and so on, I think we need to sort of have a very holistic 360 view of what's going on so that we sort of make the right decisions and steer things in the right direction. Generative AI can do a lot of things which I feel that maybe students don't have to learn anymore. So, Arvind Narayan of Princeton had a great framework for thinking about this, and he talked about how there are essential skills and incidental skills. We should look at what we are teaching and we say, okay, what is essential and what is incidental? And we should make sure that students absolutely learn the essential skills, that they don't short circuit their learning by using GenAI to sort of do those things. But the incidental stuff, I think it's fine. They can use GenAI for it. And now, what is incidental, what is essential is obviously the important question. And I think the answer varies from discipline to discipline. But I think we all have to really think about it carefully. And so, for instance, if you take something like machine learning, generative AI systems can essentially, you upload a data set, it can easily do random forests or gradient boosting or any of the standard methods. So the question becomes, if you want to just use these systems as opposed to build these systems, do you really need to know the nth level of detail of all the ways in which these algorithms work? Or should you really be focused on how do I get the right data to feed these systems? Once a system builds a model, how do I actually evaluate the model? How do I test kick the tires on the model? How do I make sure it's ready for deployment? How do I make sure it's not perpetuating bias? How do I make sure that it doesn't collapse with one wrong example when you start to deploy it? Those are all very important questions. So I think over time, we are going to gravitate towards these kinds of very important things, which are not quite amenable to LLMs and GenAI yet, and make sure that we reflect that in the way we teach.
Great. Well, thank you so much for your time today, and thank you for listening to Rama, and see you next time.
You're very welcome, Michelle. It was great to be here, and I enjoyed the conversation. Thank you.
Hi, everyone. Thank you for watching. If you like this video, check out our other videos in the series where I interview influential professors at MIT Sloan. If you would like to learn more about the Master Business Analytics program, we also have a playlist where you can see more videos about the admissions process, student life, and the program overall.